We just discussed the case an up time equal to down time, but actually this is a free-falling object with initial velocity up, and then after it reached peak, come back. And if I draw a line and draw another one, guess what? Any two lines, the time here, t up, equals time here, t down. How do we prove that? Okay. Now, first let's prove. If we name here's V1, when it's coming back, that's V2. I'm going to prove at the same level, up V and down V, same magnitude. Well, that makes sense because you know what? If we talk about free fall, then there's no air friction. No air friction, that the object's energy is not going to be wasted. So kinetic energy is associated with speed. So if you do not gain any height or lose any height, you should still have same amount of energy, which, let's talk about motion energy, that is V. So that's why V1 equals to V2 as the magnitude. How do we prove that? Very simple. If we choose here's A, there's B. Isn't that AB on the same horizontal level? Therefore, if we apply, final is B, final square minus initial square equals to 2A delta Y. Since A, B are at the same horizontal level, then delta Y, the difference around the Y direction of A and B is equal to 0. If that's 0, then VB always equal to VA. Talk about magnitude. So we can prove here, if we want, this will be V3, that will be V4. So we can do the same thing. We find that from here, that let's call that A, this B, let's call this is C, and that is D. So we do the same thing. We say D is final. VD squared minus VC squared equals to 2AY delta Y. That equals to 0. So the V at C, which is 3, equals to V at D, which is 4. So what we have is V1, the magnitude wise, equals to V2, but direction wise they're opposite. V3 equals to V4, right? With this, we can easily prove that T up equals to T down. How? Look, we're going to apply equation. C is final, A is initial. So VC is final. Final equals to VA is initial. A is initial, C is final. It's going up. So final equal initial plus AYT, T is up, right? If we say up is a positive, then VC is up. So the positive VC is V3. VA is V1, is also positive. This A is negative G because it is always downward. T is T up. So we get first equation, right? Then if we apply between D and B, B is final, D is initial, this is coming down. So VB is final. VD is initial. Plus AY, that T is down. Because only when you come down, D is initial, B is final. VB. Well, if up is positive, down will be negative. But on the other hand, guess what? When you choose A as initial, C is final, you say up is positive. That's why the VC, which is right here, V3 is positive, V1 positive, then G is downwards negative. But if you apply this equation on the other side, actually you can choose down as positive if you want. But if you still want to follow the notation that up is positive, down negative, that's fine. So let's see. Down. VB is right here. It's down. negative what? V2. And VD is here, down. It's negative V4. And A is, this G is down. Down is negative T of down. Well, since that here's a negative, negative, negative. So it's positive, positive, positive. Both sides of the equation times negative sign, you get this. Then what? Look at this. The magnitude of V1 equal to V2. So what do we do is, if we move this term to the left, what do we get? If we bring this down, bring this equation 1 down, V3, right? Minus GT up. We move to the left, it will be plus GT up, right? And what's left on V1? Look, V1 equal to V2. So, V1 equal to V2, right here. And then what? V3 equal to V4. V3 equal to V4. Okay, so GT down must equal to GT up, which proves T up equals to T down. Okay, let's practice of solving problem with those motion equation around the y direction. Example 1. We toss something up with V initial. Let's say up is positive. The location of initial, let's call it point A, is h meters above the ground. So, you know, whenever we toss something up, if it's in the air, G shows up, which is downward. Our question is, how long does it take the object to come back to the ground? Let's name this V final. Be careful. If you want to keep this G, your final point is teeny little bit above the ground before the impact, because you have to be free in the air. So, question is, how long does it take from A to B? And what is V final? It's not 0 because it's before impact. It's very high speed. And then the question is, what's the height here? Because if we know what's height there, and we know how high this peak above the ground, because you plus this capital H, you get a total height. So we're going to solve T of total. We're going to solve V final. We're going to solve that little h. Okay, how do we do that? If we remember all our equations, well, we want a T. There are 2 equations about T. Well, I say that since A is initial, B is final, but guess what? Our V final is unknown because before impact, we don't know. This is what we want to find out. So, we better just choose this delta Y equals to V initial Y plus initial Y T plus 1/2 of AY T squared equation. Because you see, if we choose that A is initial, B as final. So what's delta Y? Final position minus initial position. Final position is 0 because this is right here, a little bit above the ground. Initial position, it's right here. It's h meters above. What's that? Final minus initial. That's delta Y. Equals V initial Y, that's positive. T plus 1/2. AY is negative G because downward, and T squared. Look at that. Actually, this can translate to, we once learned delta Y change of position. Actually, there's another words to describe it. It is called, remember, displacement. Displacement is always initial point to the final. Guess what? Let me give you extreme case. So here's a bumblebee. Okay, fly, 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 fly. It finals here. This is the displacement. We ignore everything. Initial point to the final is the displacement. So what's in our case? Our initial is here. finals there. Well, theoretically, you're going to pull like that, right? However, actually, this is a case that actually I wanted you to see everything. As a matter of fact, without wing, what happened is you toss something up like that, it's coming down exactly on the same line. So say for example, you toss something up right here. That is your A. That's before in that's B. So what is your displacement initial point to find? That's that. What's that? That is the change. What is H? Direction down. So it's negative H. That is displacement. So either way, you can use delta y as displacement. You just from initial point to the final, you find the directions down, it's negative, and find the magnitude is you down by H, capital H meters. You get it. Or you use delta y as as y final minus y initial. You get the same thing. This is a quadratic equation. So if you move everything, for example, you have 1/2 gt squared, that term to the left, minus v initial yt, distance to the left. Distance already on the left, minus h equal to 0. And this is your A, this is your B, that's your C. So you follow AT squared plus BT plus C equal to 0. You solve this quadratic equation. Your A is 1/2 g. Your B is negative v initial y. Your C is negative h. And you solve this quadratic equation. What is it? T equals to it's minus b plus minus square root b squared plus minus 4ac over 2a. This is minus 4ac, right? So from this equation, one step we can solve what's the total time t, which is from A's initial, B's final, from here to here. We solve that. How do we solve V final? Well, if we know V total, which is initials here, final there, then what we say? We say VV, that's final. Final velocity equal to VA, initial velocity plus AT. This T is the T total. So VB is this V final we're looking for, equals to VA, which is right here. That's V initial Y. AY is minus G. T total is already solved from step number 1. So we can solve what is this. Well, T total usually is large. After time a G, this negative term is much bigger than this V initial Y. Therefore, your total result will be negative. Your V final negative means coming down right here. The last one, this little h. Now, since we're interested from A, let's choose this point as C if it's between A and C. And that's very easy. We can use the previous method to solve it. That is, this is final. VC is final. Final square minus initial is V initial Y square equals 2 AY delta Y. And obviously, this is 0. This is V initial Y known. AY we're plugging negative G. And your delta Y is the little h you want to solve. So it will give us h, because this negative is negative cancel. This is 0 term. There's 0 term. Negative cancel. So h equals to V initial Y squared over 2. See, this negative, that negative. This only have a 2 and G left. That is the little h. So the point C is capital H plus little h above the ground. That is the maximum height. Let's look at another problem. Sometimes the problem is not that straightforward. Let's say this one. It says, we release something with initial velocity equals 0 at t equals 0 at certain height. This object drops a total distance h. Now remember this time, it drops G because of G, right? Because initial velocity equals 0. The reason it drops is because it has acceleration downward. Now everything's down, nothing up. Down is positive. it simply say that from here t equals 0, from here to the middle point, half h, it takes t second. The last half, another half of h takes only 1 second. Did you see here? Time moment here t equals 0. Time moment here t1 is t. Time moment here t2 is t plus 1. So here's t plus 1, so it takes 1 second. Between, if I name this is A, that is B, that is C, between A and B, t second. Between B and C, 1 second. Distance from A to B is half h. From B to C is another half h. Question. What is that h? How long does it take to drop the entire h? So we're going to find h and t. How do we solve that? So remember, we follow the definition. We say, okay, it takes t second to drop this much. So we will say this. Delta y equals to v initial y t plus 1 half a y t squared. Since we talk about time and displacement, delta y is half h, is positive downwards. Initial y is 0 because start from initial velocity equals 0. And plus 1 half ay is positive g. See, because down is positive. T, well, we're applied this equation because it's half h. It's from initial. See, initial velocity is 0, so it's from A to B. So this is actually, we apply this equation from is A to B. So if it's A to B, the time is t second because from A to B, time is t second. See, t equals 0, t second. Equation number 1. From B to C, the time is 1 second. Displacement is h over 2 down. But be very careful. We better figure out what is the v here. You see, with the initial velocity equals 0, with such an acceleration, after t second, we should have known what's vb. So we say vb equals to va plus acceleration times the time. We apply this equation from A to B again. VB is what we want. VA is 0 because right here. Acceleration is g. This t is t seconds. So the magnitude of v at point B is gt. So right here, VB equals to gt. We're going to now apply the very same equation, this one. This time we're going to apply from B to C. B to C. B is initial, C is final. So let's do this. Delta y. B is initial, C is final. Change of displacement is positive h over 2 because down is positive. Equals to, apply this one, V initial, because it's B to C. B is initial, B initial. Initial is right here. GT, then time t. From B to C, time is 1 second, so time is 1 second. Plus 1 half. From B to C, G is still same, so it's G times 1 second. Don't forget, times 1, here's square. Now look at this. We have the second equation. First one here, second one there. We have two unknown. H and T. H and T. So we will be able to solve this problem. How? It's pretty simple. Look at this. This is half h, this is half h. We can make them equal. So this equation, we have 1 half gt, like this term. And that equation, the other side is gt plus 1 half g. Because, oh, I'm sorry. Yeah, that's right. Because gt is the VB. So when we apply this equation, initial velocity, this one is VB. VB times the time, 1 second. Yeah, plus 1 half g, 1 second squared. So we get that. It looks like g cancels, right? How do you solve t? And wait a minute. Do we have a problem? If h 1 half gt It's right there. This is gt plus 1/2 g1 square. And let's see. Okay, guess what? This is the equation that we're going to apply. Here's a square. This t has a square. So h over 2 equal to 1/2 g. This has a square. And then we get right. So this is the equation about t. 1/2 t squared equals to, so you bring everything to the left, you have a quadratic equation. You have 1/2 t squared minus, g get cancelled, okay? T, g get cancelled, minus 1/2 equal to 0. You can solve t. Once you solve t, t is from here to here. Then the total time is t plus 1. Then if you want to get h, that's very simple. You choose A and C. You let it drop. Total distance drop is h. Initial velocity is 0. So you apply this equation. Total drop is h, initial 0, plus 1/2 g. You find your total time already. You get it. See? You plug in the total time. But in our case, the t we solve here is the t from A to B. Then the total time has to add 1 more second. And you solve it. Let's look at another one. If we have object A and B and release at the same height, release means let's make initial velocity v initial A equal to 0, v initial B equal to 0. But let's have A release first. 1 second later, release B. So they are 1 second apart. The question is, when will they, the second one will catch, let's see, if we let them go at the same time, it will take the same amount of time to drop the same distance, right? If we let the second one drop 1 second later, then it will be always slower than the first one. So we have to throw the second one in order to catch the first one. So what we do is we say initial velocity of A equals 0, initial velocity of B is unknown. We want to throw this one down and ask how many seconds later B is going to catch A. So we let A drop first. So A drop. It takes t seconds. And this guy will drop 1 second less, but with initial velocity downward, we'll be able to catch it. So the question is, how long, well, what is the initial velocity B should be when we toss it down, V initial B? And then how long does it take this guy to catch it? So this is a very similar one as the car at x direction. So catch means if we choose downward y-axis, catch means they must have the same location on the y. So let's talk about this. If the moment that A leaves as t equal to 0, and then this guy leaves at t equals to 1, so it drops 1 second less. For A, y of A, initial velocity y is 0, so it simply drops 1/2 g t squared. That is for t seconds. But with object B, it has initial velocity, VB initial. Remember this time everything is down to positive. Okay, this is positive. So, but it's going to drop t minus 1 second because it's going up, down 1 second later. Plus 1/2 g, because I have the same acceleration, t minus 1 squared. This is about the second one. Obviously that our t has to be more than 1 second because this has to be a positive term. So if we want B catches A, we can have them equal. So we have one equation. But we do have t and v initial b unknown.